Welcome to Algebra 1, Semester 2, Unit 8B, Section 9.8. Okay, what we're asked to do here is completely factor these binomials. The very first thing you should always look at is there a GCF that I can pull out? Well, it does look like 2 would go into both of those terms, so 2 goes into 2y to the fourth, y to the fourth times. 2 goes into negative 32, negative 16. Now if you look at that, we've got a difference of 2 squares. 1y to the fourth would be a perfect square, and 16 is a perfect square. So that would become y squared minus 4 and y squared plus 4. So you might think, oh good, we're all done. However, always double check, that's a perfect square again, isn't it? So that's a difference of 2 squares. So we need to go y minus 2 and y plus 2, just to break this binomial down. Now I brought down the 2 because that's part of the answer. And then I also need to bring down the y plus 4. There is your final answer. You can't break anything else down any further. When I say factor completely, I mean to keep looking at these and making sure that you can't factor any further. Okay, so it looks like we have a difference of 2 squares again. Reason I say that is 49 and 25 are perfect squares, so let's try it. 7, that would be y because that's the root of it, minus 25w to the 6th, the root of that would be 5w to the 3rd. And then we'd have 7y plus 5w to the 3rd. Okay? Take a look and see if you can break anything further down. These are not difference of 2 squares, so I'm satisfied that we're done. Okay, the last page of this packet, page 6, up at the top, we're still factoring completely. So we have a trinomial here. We ask ourselves, well, 1 times 16 is 16. So what two numbers would multiply to be positive 16 and add to be negative 8? And the two numbers that I think of, I know their signs have to be the same, and the two numbers that I think of are negative 4. Now the only tricky thing here is that we need to bring down 2 letters. This is why I didn't take the shortcut, so that you could kind of see how this works. So we have a squared minus 4ab minus 4ab plus 16. And I always want you comfortable, if you take shortcuts, to know how to do it the long way as well. So what would factor out of there would be a. We have a minus 4b. What would factor out of here? Well, just a minute, I need to write that binomial again. That's how I've taught you to do it. Now what would be factored out here would be a negative 4b. Forgot to bring down that b squared. So negative 4b times a is negative 4ab. Negative 4b times negative 4b would be a positive 16b squared. I take those out. A minus 4b. What I have left is a minus 4b. So that happens to be what we call a perfect trinomial square, because it is factored like this. Okay? In time you'll be able to spot those, and then you can just go straight to the factor. Okay, on this one, we know that we can take the shortcut because there's a 1 out front. So we put y and y. Now, just like we saw here in this last one, The variable was put in the back on this last part. So since it's a d squared, we'll have a z and a z. I mean a z squared. We'll have a z and a z. Now we ask ourselves what two numbers multiply to be 49 and add to be 14. They'd both be positive. And we say 7 and 7. That is a perfect trinomial square. So we write it as y plus 7z squared. Okay. Bottom of the page, the last four on this packet, page number 6. Solving a quadratic equation, I would move that w to this side, and then I would actually write it in standard form, 80m squared negative 80m squared plus 45 equals 0. Remember on the last lesson I told you we never factor with a negative out front. So I'm wondering if there's any other number we could pull out of these. I would bet that 5 would go into each of these because they end in 0 and 5. So I'm going to pull out a negative 5. 5 goes into 80 16 times. And 5 goes into 45 9 times. Now that might fool you and look a little bit like a difference of two squares. However, the problem with that is it's not a difference. So at this point, I would just go ahead and you can't really factor that down. So I would go ahead and say let's clear that parenthesis, put it back together, and get that m squared a different way. Let's just go ahead and clear things out around him. Okay, what's being added or subtracted to him? The positive 45. So we subtract 45 from each side. Now we get a negative 80m squared equals negative 45. And now we can divide by negative 80. And we would get, let me move it right up here, m squared equals, a negative over a negative makes positive. So now we're going to have 45 over 80 positive. Now we did talk about how 5 goes into each, so we'll go ahead and we'll reduce that. It was 9 over 16. Now we still don't have that creepy dude all by himself. We want to get the m by himself, so how do we get rid of an m squared? Square root. So we find that m equals, square root of 9 is 3, square root of 16 is 4, and remember it's a plus or a minus. That's your answer. So when we first started, we were going to factor, thinking it would be a binomial factoring, and when we got there, we couldn't go any further in that essence, so that's why we put it back together and we factored this other way. Or we didn't really factor, we just solved this other way. Okay, next one. There is another way you could have done that right there, but I think it's easiest probably to go back like this. In a later class I can show you another way, or if you're curious right now I can show you. Okay, negative 5r squared minus 20r. Well, it looks like I'm going to have to do trinomial because I do have the r's in a squared and in a non-squared fashion there, so I'm going to have to do some kind of factoring. So let's go ahead and subtract 20 from each side and get that equal to 0. Now I could factor out a negative 5 off the front, which I should do, because I shouldn't ever have a leading coefficient of a negative. So that would be r squared plus 4r plus 4. Now since it's a 1 technically on the front of that, I can go straight to my shortcut. Put an r, put an r. What multiplies to equal 4 and adds to equal 4? That would be a 2 and a 2. Go ahead and bring down your -5, but you are solving for the r's. You know if each of these multiplies and it equals 0, one of these has to be 0. That will occur when r equals -2. That's the only time it occurs. Next problem, we see that we could factor a 4 off of it right away. Oh, I'm sorry. If we factor a 4 off the front, we get g squared plus 5g plus 6 equals 0. Okay. Now we have a 1. Out here is our leading coefficient, so we know that we can go straight to our shortcut. What multiplies to be positive 6 and adds to be positive 5? That would be a positive 3, a positive 2. Bring in our g and our g because we're taking the root of it. That's our shortcut. Go ahead and bring down our 4. It won't matter though, because what we're looking at is when do these equal 0? What values is it that causes these to equal 0 when we multiply them? Well, that means this one would equal 0, or this one would equal 0. And now you solve those. Subtract 3 from each side, so we get g equals -3. That's when it would equal it. Or g equals -2. Those are your two answers. Okay. Last one, we've got an x cubed over here, and we've got the others over here. I would just get rid of this x cubed on this side. That will create all of them on the same side. So that wipes out. We have x cubed plus 2x squared minus 15x. And now we can set it equal to 0. The 0 doesn't have to be over there. What could I factor out of all these? I could factor an x out. That would leave me with an x squared plus 2x minus 15. Now, because I have a 1 off the front, again I can do my shortcut. So I put an x and I put an x. That's because it's that one broken down. Now, I'm going to have a -15 as a product on the end term, so I know these are opposite signs. What two factors of 15 subtract to be 2? That would be 5 and 3. Because 5's farther from 0, it takes the sign of the middle number. Now don't forget to bring this x down. Now to show the zeros for this equation, we need to set each factor equal to 0 and tell it what value of x that would happen. Well, right here we have when x is equal to 0, the whole equation will equal 0. Or when x is equal to 3, the whole equation will equal 0. Or when x is equal to -5. Okay? That is the end of Unit 8B. Thank you very much.